These days, spacecraft are venturing into the final frontier at a record pace, and a deluge of paying space tourists should soon follow. But to earn their astronaut wings, high-flying civilians will have to make it past the so-called Kármán line. This boundary sits some 100 kilometers above Earth's surface, and it's generally accepted as the place where Earth ends and outer space begins. From a cosmic point of view, 100 kilometers is a stone's throw, and is also a limit that falls abundantly within the domain of the gravitational attraction of the Earth and its atmosphere. So how did humans come to accept this relatively nearby location as the defining line between Earth and space? The answer is partly based on physical reality and partly based on an arbitrary human construct. That's why the exact altitude where space begins is something scientists have been debating since before we even sent the first spacecraft into orbit. Where exactly is the edge of space? It depends on who you ask. With more countries and commercial companies heading into the stratosphere, the debate about how to define outer space is heating up. Ask someone where outer space is, and they'll probably point at the sky. It's up, right? Simple. Except no one really knows where airspace ends and outer space begins. That might sound trivial, but defining what boundary could matter for a variety of reasons, including but not limited to which high-flying humans get to be designated as astronauts. Now, with Virgin Galactic seemingly on the cusp of launching paying passengers into suborbital trajectories, many people are wondering whether those lucky space tourists will earn their astronaut wings. As of right now, they will, according to U.S. practices. Is that a problem? No, I think it's great, says NASA astronaut Mike Massimino, who in 2002 with the mission STS-109 Columbia contributed to the repair of the Hubble Space Telescope. Here we take a look at the way space is currently defined, the confusion surrounding the demarcation, and what the future might bring. International treaties define space as being free for exploration and use by all, but the same is not true of the sovereign airspace above nations. The laws governing airspace and outer space are different. Flying a satellite 88 kilometers above China is just fine if space begins at 80 kilometers and up, but define the edge at 96 kilometers and you might find your satellite being treated as an act of military aggression. Where does a country's airspace stop and space begin? Asked Jonathan McDowell of the Harvard-Smithsonian Center for Astrophysics. Once you agree on a boundary of space, you agree on a boundary where space law applies. However, the United States and some other countries have resisted a formal international delimitation of space, stating that it's not necessary and that no legal or practical problems have arisen in the absence of such a definition. Others argue that maintaining a distinct boundary will be crucial, given an increase in the number of national space programs and in private spaceflight endeavors that are boosting the amount of suborbital traffic. So how is space currently defined? Experts have suggested the actual boundary between Earth and space lies anywhere from a mere 30 kilometers above the surface to more than 1.6 million kilometers away. However, for well over half a century, most, including regulatory bodies, have accepted something close to our current definition of the Kármán line. The Kármán line is based on physical reality in the sense that it roughly marks the altitude where traditional aircraft can no longer effectively fly. Anything traveling above the Kármán line needs a propulsion system that doesn't rely on lift generated by Earth's atmosphere. The air is simply too thin that high up. In other words, the Kármán line is where the physical laws governing a craft's ability to fly shift. However, the Kármán line is also where the human laws governing aircraft and spacecraft diverge. There are no national borders that extend to outer space. It's governed more like international waters, so settling on a boundary for space is much more about the semantics of who gets to be called an astronaut. The United Nations has historically accepted the Kármán line as the boundary of space, and while the US government has been reticent to agree to a specific height, people who fly above an altitude of 100 kilometers typically earn astronaut wings from the Federal Aviation Administration. Even the Ansari X Prize chose the Kármán line as the benchmark height required to win its $10 million prize, which was claimed when Burt Rutan's Spaceship One became the first privately built spacecraft to carry a crew back in 2004. But just a moment. Kármán, who was he? The Kármán line gets its name from Hungarian-born aerospace pioneer Theodor von Kármán. In the years around World War I, the engineer and physicist worked on early designs for helicopters, among other things. Then in 1930, von Karman moved to the United States and became a go-to expert in rockets and supersonic flight around World War II. Eventually, in 1944, Kármán and his colleagues founded the Jet Propulsion Laboratory, now a preeminent NASA lab. In addition to the boundary line of space, von Karman's name is attached to a number of engineering equations, laws, constants, and aerospace designs, as well as a handful of awards in the field. But the Kármán line is by far his most famous claim to fame, which he earned by being among the first to calculate the altitude above which aerodynamic lift could no longer keep an aircraft aloft. Lift is largely generated by an airplane's wings as it flies through the air, creating a force that opposes the plane's weight, keeping it airborne. But this concept doesn't work in space. Without enough air, there's no lift, which is why spaceships don't usually resemble aircraft. The Space Shuttle and Virgin Galactic's Spaceship Two, in fact, look a bit like planes because they were designed to glide back to a runway on Earth after venturing to space. Von Karman suggested that the most reasonable edge of space would be near where orbital forces exceed aerodynamic ones, and opting for a nice round altitude, he decided that 100 kilometers was a good boundary. Still, despite now having his name attached to the boundary of space, von Karman himself never actually published this idea. As von Karman himself wrote in his posthumously published autobiography, The Wind and Beyond, this is certainly a physical boundary where aerodynamics stops and aeronautics begins. And so I thought, why should it not also be a jurisdictional boundary? Below this line, space belongs to each country. Above this level, there would be free space. The Fédération Aéronautique Internationale, FAI, which keeps track of standards and records in astronautics and aeronautics, also defines space as beginning 100 kilometers up. It is, after all, a nice round number. But the Federal Aviation Administration, the U.S. Air Force, NOAA, and NASA generally use 80 kilometers as the boundary, with the Air Force granting astronaut wings to flyers who go higher than this mark. At the same time, NASA Mission Control places the line at 122 kilometers because that is the point at which atmospheric drag becomes noticeable. How come people can't agree? It's very political, it turns out, McDowell says. There is no easy distinction between space and not space, in part because Earth's atmosphere doesn't simply vanish, rather it gradually becomes thinner and thinner over about 1,000 kilometers. Technically, the International Space Station, which orbits at an average height of 400 kilometers, would not be in space if we define space as the absolute absence of an atmosphere. Furthermore, there's no single altitude above which a satellite can stably remain in orbit. That depends on the type of satellite and its orbital trajectory, McDowell says. A prodigious maker of lists, McDowell was compiling records for rockets, astronauts, and other space objects, and he went looking for an accepted international boundary that would help him decide which records to include. When he realized none existed, he decided to find one by revisiting the types of calculations von Karman did. He pulled publicly available orbital paths for 43,000 satellites and sorted them based on the lowest points in their orbits, called perigee, during decommissioning and atmospheric re-entry. From there, he realized that satellites could orbit the planet numerous times below an altitude of 100 kilometers, but those dipping beneath 80 kilometers met a quick and flaming end more often than not. After that, he redid the von Karman math and found that atmospheric contributions on orbiting spacecraft become negligible at around 80 kilometers up. What you don't see is satellites dipping down to 70 kilometers and coming back out, he says. There is a fairly sharp boundary, a decently sharp boundary between how low the perigee can be and where you just won't make it back out again. With some orbital spaceflight companies edging closer to the edge of space, could 2021 be the year we formally define it? McDowell thinks that's unlikely, although he's sure the conversation will pick up speed as commercial spacecraft ventures begin spending more time in the region between 80 and 400 kilometers, where the space station orbits. I think that as space activity moves more into this regime, the pressure to agree on a boundary will be greater, he says. In fact, the FAI says that because of compelling recent analyses suggesting that space ought to begin around 80 kilometers up, it will propose a meeting this coming year to evaluate the idea. Okay, but will paying suborbital spaceflight passengers be called astronauts? As of now, yes, at least if they make the trip from a U.S. launch site. The FAA and the U.S. Air Force both agree that flying higher than 80 kilometers above our planet qualifies a person for the title, McDowell says. What do NASA astronauts think about that? Some people might argue that getting into orbit is what defines an astronaut. However, I think Alan Shepard and Gus Grissom would disagree, says Terry Virts, a former commander of the International Space Station who has spent more than 213 days in orbit. They're the first two U.S. astronauts who didn't get into orbit. Virts says there's a big difference between riding along on a 5-minute suborbital flight and performing a 6-month orbital mission, but when it comes down to it, folks on both types of trips have earned the astronaut title. If you're strapping your butt to a rocket, I think that's worth something, Virts says. When I was an F-16 pilot, I didn't feel jealous about Cessna pilots being called pilots. I think everybody's going to know if you paid to be a passenger on a 5-minute suborbital flight or if you're the commander of an interplanetary space vehicle. Those are two different things.